we present DaLA, Danish Linguistic Acceptability Evaluation, a new benchmark for assessing how well large language models understand the naturalness and grammatical correctness of Danish sentences, grounded in real-world errors made by native speakers. This isn't just another dataset. It's a carefully constructed tool designed to reflect the actual mistakes people make when writing Danish, mistakes that go beyond textbook grammar, rooted in how the language is actually used. To build it, we began by analyzing the most common errors in written Danish. Drawing from authoritative sources like Typisk Problemer, a guide jointly developed by the Danish Language Council and the Society of Danish Language and Literature, we identified recurring issues that real writers struggle with. These aren't abstract linguistic anomalies. They're the kind of errors you'd see in emails, essays, or social media posts. From this analysis, we designed 14 new corruption functions, each one simulating a specific real-world mistake. These include confusing nogen and nogen, swapping ligge and lægge, misusing the end and een suffixes due to silent d pronunciation, mixing up subject and object pronouns, and even the infamous R problem, a class of errors where the letter R is misapplied in verbs, nouns, and adjectives due to similar sounds and spellings. Each function is implemented as an automated process, using tools like SpaCy for syntactic and morphological analysis. But here's the key. We didn't just apply these errors blindly. We built safeguards to ensure that every corrupted sentence is genuinely ungrammatical, because if a sentence still sounds natural after corruption, it fails the test. To validate this, we used a hybrid approach. First, we fed all corrupted sentences into WriteAssistant, a leading Danish grammar correction tool. It detected errors in 99.7% of cases, excellent precision. But we didn't stop there. For the rare cases where the tool missed something, we conducted manual validation by a native Danish linguist with expertise in lexicography. The result? A final validation precision of 95.7% across all corruption types. Some errors, like ligge versus lægge, achieved perfect 100% precision. Others, like han hun versus det, were slightly lower, reflecting the complexity of pronoun usage in context, but still highly reliable. The final dataset DaLA contains 3,328 sentence pairs, 1 correct, 1 corrupted, split into training 512, validation 1,024, and test 128 sets. We also provide extended versions, DaLA medium with 7,656 samples, and DaLA large with 8,656, allowing for scalable evaluation. But the real test came when we evaluated top-performing open-source and open-weight models using the Euro-Eval framework. The results were telling. On the current state-of-the-art benchmark, ScaLA, models like Google's Gemma 327b, it achieved an MCC score of 60.1%. On DaLA, that dropped to 56.77%, a 5.5% decrease. The worst performer, a reasoning model, saw its score fall from 60.07% to 45.22%, a 14.85% drop. On average, models performed 6.04% worse on DaLA than on ScaLA. Some dropped as much as 14.55%. This isn't just a minor difficulty bump, it's a qualitative shift in task challenge. The new benchmark isn't harder just because it's bigger. It's harder because it's more representative. ScaLA only used 2 generic corruptions, word deletion and word swapping. These are easy to exploit with pattern recognition. DaLA, by contrast, reflects real linguistic behavior, errors that arise from pronunciation, morphology, and usage patterns. And that matters. Because when a model fails on DaLA, it's not failing on a synthetic puzzle. It's failing on something that mirrors real human language use. This makes DaLA a more discriminative tool. It can better distinguish between models that truly understand Danish grammar and those that are just memorizing patterns. In fact, the distribution of errors across training and test sets is nearly identical, Jensen-Shannon divergence under 0.01, ensuring that models aren't just overfitting to a particular type of mistake. What does this mean for the future of Danish NLP? It means we're moving from benchmarks that measure pattern recognition to ones that measure linguistic understanding. From datasets built on academic sources to ones built on real language use. DaLA isn't just a new dataset. It's a new paradigm. It shows that for low-resource languages like Danish, the path to better evaluation isn't just more data, it's smarter data, grounded in the actual errors people make. And it opens the door for other researchers to apply this method to other languages. By studying real-world mistakes and turning them into systematic corruptions, we can build benchmarks that are more authentic, more challenging, and more meaningful. This is not just about improving models. It's about building models that understand language, not just mimic it. So if you're working on Danish language models, if you're training multilingual systems, or if you care about how well AI truly grasps human language, DaLA is your next benchmark. Because understanding acceptability isn't about checking boxes. It's about capturing the subtle, messy, beautiful reality of how people actually speak and write. And DaLA brings us closer than ever to that goal.